So thank you very much for your participation in this meeting. This is the first public event of the PITHIA-NRF project. And we are very happy to see that we have with us colleagues who have supported the project during the proposal submission phase, and also our advisors. So I can start this short meeting with an introduction on the project. But first of all, I would like to welcome especially the advisors of this project who are present today. So I see that we have Aude Chabaudu from the University of Strasbourg. And we also have Mamoru Ishii, who is Director General of Radio Propagation Research Center in NICT, Japan. We also have with us Professor Joseph Lemaire from the Université Catholique de Louvain in Belgium. And we also have Joe Huba, Vice President of Syntec Technologies and affiliated with NASA CCMC. And I believe that we have, okay, I don't see Ian in the list. Maybe he will join us later. The fifth advisor of this project is Ian McCree. From RAN Space in UK. And now I can start with a very short introductory talk to give you an overview of the project, and then my colleagues will continue with more specific talks. Okay, I will share now my screen. So, do you see my my presentation?
Yes.
Yes.
Thank you.
I see it.
Okay. Okay. So this project has the acronym PITHIA-NRF, and the full name of the project is Plasmosphere, Ionosphere, Thermosphere Integrated Research Environment and Access Services, and Network of Research Facilities. The project was submitted during the pandemic last year in May 2020, and after a long phase of review and negotiations with the Commission, it has started last month. And the duration of the project is 4 years. Now, what are the scientific challenges that are addressed with this project? We all know and are aware that the Earth's ionosphere, thermosphere, and plasmasphere is governed by a complex electrodynamic and photochemical system and processes, so there is a coupling of electromagnetic fields and thermospheric winds, which create a number of turbulence in this region of space, and this creates many challenges in systems, in operational systems that are in this region, and mainly satellite HF communication, transionospheric propagation. So it is very important for all the operators of this system to have a good, a realistic awareness of the processes active in this region. So, and while we understand the broad feature of the coupled ionosphere, thermosphere, and plasmasphere system, we lack the depth of understanding of its variability in long and short-term timescales, and therefore we still need more scientific advances to allow us to build models with real predictive power. Of course, we have made a very good progress the last year. Here, for instance, you can see a picture of an animation of the 3D kinetic plasmasphere model, which is one of the key models that PITHIA will use for research advances. But of course, not only this one. We have also a number of other models that start from the sun and predict the propagation of the CME and the impact in the ionosphere, in the plasmasphere, and the thermosphere. Now, what is the ambition? The ambition of this project is to facilitate the development of validated prediction models and the transition of these models from research to application. And to do this, we bring together in this project observing facilities, data, and models. We develop standardized methodologies and tools to facilitate the use of this data and models and to achieve the integration because this whole effort is about integrating what we have already done in a common research environment. And the tools that we are using for this integration is first of all, standardization, but also training for operators and users, innovation, exploitation, sustainability, dissemination, communication. So the overall goal is to develop a structured research infrastructure to provide transnational research services, including access and standardization, and through all these tools to support our scientific users who are researchers from academia and from SMEs to validate their models and to transition the research models to application. This is the consortium. We have here in PITHIA 22 beneficiaries, and you can see their logos. We have the most important institutes in Europe. We have 2 third parties, and we have 5 external advisors and 52 followers who have already provided us expressions of interest. As I said, the proposal was submitted in the H2020 call on research infrastructure for starting communities. Starting communities are considered those communities who have never received funding before for integration. So this community that works on plasmasphere, ionosphere, and thermosphere monitoring and prediction has not received before funding for innovation. So it is considered as a starting community. And the program where we have submitted our proposal is the research infrastructure, which belongs to the excellence science pillar of Horizon 2020. So this means that the European Commission is expecting from us to produce excellent science through our developments in the PITHIA project. Now, to detail now the objectives of this project, the first and main objective is to provide effective and convenient access to the best European research facilities, which are called now nodes, PITHIA nodes, for the nodes for the upper atmosphere. So we are developing the Transnational Access Program, we hope that it will include users from both academia and SMEs and large companies and public organizations. This is the map with a geographic distribution of the nodes of PITHIA. So we have several nodes that span through all the most European countries. And this is here in this picture, you can see an example on what a user could do during his access in one of the PITHIA nodes. So some indicative projects are design and conduct an observing campaign, work with data curation, design a model, improve the model through a validation process, and then define some data products from this model, and then register these data products in the European Open Science Cloud, following the standard making process for innovation. Everything in PITHIA is about standardization and innovation. And through this, we hope that we will receive the excellence in science. The second objective is to develop integration tools that enable the establishment of a comprehensive research environment. The main tool is the eScience Center, which is a dedicated knowledge hub that provides access to the data that will be registered in PITHIA and to high-level data products that are mainly the output of the models that are owned by the partners of PITHIA. We will also work to optimize our observing strategies, which is also part of the integration. Optimization of observing strategies is important to allow us to operate our facilities with a standardized protocol. These integration tools are expected to lead to the optimal use and joint development of PITHIA observing facilities. So we have, from one hand, the eScience Center who handle all data and models, and on the other hand, we have the optimized operation of our observing facilities. And therefore, we can support both remote access from the users and hands-on access from the users. The third objective is to keep long-term observational data and to develop strategies to sustain these data collections. And therefore, we aim to register all these long-term observational data in the European Open Science Cloud, and therefore to have persistent identifiers of these data collections that, of course, guarantee their discovery and accessing long term. And as you can see here in PITHIA, we will register data from a number of different instruments like ionosomes, continuous Doppler soundings, GNSS receivers, rheometers, ISCAT radars, pulsation magnetometers, and the LOFAR telescopes. So the fourth objective has to do with the training. The training is a very key activity in PITHIA. And when we talk about training, we start, first of all, with a training inside the consortium. First of all, the partners have to train on the use of the integration tools, and then we will expand this training to the outside world, inviting users to attend schools and seminars organized by PITHIA. Also, the users who will get access to our facilities, we will go through training seminars on how to use our instruments. The fifth objective is innovation. In PITHIA, we will develop an innovation platform to promote cooperation between stakeholders we will also provide tools for continuous interaction with users, because our aim is to promote the activities of the PITHIA in this specific market sector and to grow a collaboration, a continuous collaboration with the private sector. And in this framework, we will develop 3 innovation days within the project that will be targeted to discuss with specific representatives from big organizations, from SMEs, what they need to get from PITHIA, what type of software they need to use from PITHIA, or what type of data products they need, and also if they need to conduct specific experiments in our nodes for validation and calibration, for instance. But all these have to be discussed face to face with these potential users in order to understand better their needs. And this is a key for the sustainability of the project. Now, the expected impact of this project emerges from the access and from the integration. From the access, we expect to educate the new generation of researchers to encourage them to work more intensively with our experimental facilities and to bring them inside the domain of plasmasphere, ionosphere, and thermosphere science. Also with from the access, we expect to share widely the information among users from academia and from non-academic stakeholders, because all types of users will be welcome to access our facilities. The integration of major scientific equipment and standardized management, we hope that will lead to new services that may be available to the wider community and facilitate the operators and to develop strategies that will lead to economies of scale, mainly through standardization. Now, a few words about the methodology. We have three types of activities in PITHIA. We have the blue work packages, which are the networking activities. These are activities that target to the definition of interoperability, to set mainly the standards for the integration. The other work package is about training. We have also one work package about dissemination, communication, and exploitation, and the fourth work package on innovation. Of course, we have the management and coordination of the project. And these blue work packages, which are the networking work packages, feed with information the joint research activities, which will build the science center and will validate all the tools for integration. And at the end, we hope that these tools will be operating at the end of the project and will be used to register all our data and products into these science centers, so they can be accessible from our users. At the top of these activities, we have the access. The access is about granting access to users who want to visit our facilities and perform specific projects. This is a whole procedure because the access is provided through a review process. So we are receiving proposals from users with what they want to do in our facilities, and after a review process, we are granting the access to those that are who have submitted the best proposal. We are planning to, as I said, provide access to all our 12 nodes, and we will issue several calls within the project lifetime, and we will accept more than 100 projects in our nodes to be implemented. And through this process, we will also able to evaluate the standardization processes that we have developed and to improve our e-science services, because all the users who will have hands-on access in our nodes, they will also use at the same time the e-science services from the PITHIA e-science node, and we hope that this activity will give us also some feedback about the exploitation and sustainability of the project overall. Of course, we will be at the same time in continuous contact with our stakeholders, with the wider community, with our advisors, as we are doing today, but we are planning to organize many more meetings within these 4 years, and we hope that from 2022, we will be able also to organize face-to-face meetings after the end of the pandemic. And to give you a very high-level overview of the activities in each work package, something that maybe it's more relevant to external users and stakeholders of PITHIA, is that from the work package 5, which is the building of the science center, we are planning to release 4 editions of the e-science center, one at the end of each year. We are also planning to organize 2 schools for young scientists, and PhD students. one in Rome, 111. And we are planning also to organize 2 high-profile meetings with all our stakeholders invited, one in the middle of the project and one at the end of the project. We are planning to publish 4 calls for access in our facilities. The first call should come very soon. Of course, because of the pandemic, we may restrict the access only to remote access, at least for the first call, because the hands-on access will be very problematic under these circumstances. And finally, we are planning to organize 3 innovation days to discuss with our users and to understand how we can best meet their requirements for innovative products from PITHIA. Now, this is the end of my talk, and we can, if you have an urgent question, we can now discuss. Otherwise, we can continue with the second talk and then have all the questions at the end in the discussion slot. Okay, so I will give now the screen to Ingemar Hansson from ISCAT, who will present the nodes and operations.
Okay, hello. Yes, you see my screen.
Yes.
I hope. Yes, good.
Yes.
Yeah, so I actually I will more talk about access to the facilities. That is what I planned for, but it will handle the facilities, of course, and operations. So I'm Ingmar Häggström. I work at ISCAT in Sweden, which is an international organization, really. So, and the objectives for the access that we have. I mean, we are offering access to science users in mainly in Europe, but also outside Europe, I guess. And we offer hands-on access to all the facilities that are part of the project, where they will contact research projects. And as Anna said, we will have a selection procedure. And in this access, all these users will then learn how to access the facilities and operate them end to end. It may mean to set up a special campaign for measurements, or just access databases in a special way, or analyze the data in their own way for their project. So it means that they will exploit the data quite a lot that we have. And as the project develops, it will also involve use the project tools that is going to be developed in the project. So this access is also a test for these tools, and improve the tools and during the project. So the instruments that we have are in the project. They are Ionosphere. It's a map here, mainly in Europe, but there are also some world global instruments. Doppler sounders, GNSS receivers in more or less all over the world, as you can see. That is the stars. Incurrent scatter radar, which is ISCAT in the northern part of Europe and also in Svalbard. Rheometers, magnetometers. The low-far telescopes are distributed in some star-like feature over Europe. There are also global networks of GNSS sites, which is many more of these of the instruments, and but they are part of this URF and IGS networks. If one can also call, we're also offering models to the users, which is also an instrument in a way. So space models or collection of global data that are combined into a global maps of measurements. And of course, that outside of these instruments, there are also cameras and other radars that are in the project, but not really offered for the access. So what areas we hope to have this, to have openings of science development center, that is, I mean, a user can access our tools to validate their own models or develop their own models. They can develop higher level data products from our data, and also then possibly provide these to the PITHIA network. Also proper plasma physics can be done. And of course, analysis of data methods, look at small scale features and or large scale features, and also it's the dynamics, how it moves over time and space, coupling between different layers, and also use these space models and to possibly validate or to use the space models in conjunction with their own instruments, and analysis and modeling in more global scale, of course, and many more. So we have set up an access bureau, which is these 12 nodes. Then it has a share and one from each node. You can see all the nodes there that are part of this offering the access. It will also have a support center with a contact point email, which would then provide the interaction between the infrastructures and potential users. And for the user access, we expect to have once or twice per year a call. The first call will be remote, mainly to remote access. I think Anna mentioned this also, but then we will have a follow-up in autumn this year, at least to also collect the more physical access, more directed to the physical access that we hope that is possible next year then. And they will be, of course, it will be on the website and also via social media, mailing list, and at conferences, the call. The application should contain a user profile, science goals, project description, and what kind of needs is needed, logistical needs. In total, it will be around 100 projects that we will provide. H2020 has or the EU has, through the H2020 program, a number of requirements for this, and we will follow them as much as possible, or we need to follow them, of course. So the selection of the project will be mainly due on scientific merit. There are some preferences that is given in the EU TNAs that there are. I mean, new users may have a preference if it has the same scientific merit, and it should mainly be inside EU and the connecting countries. SMEs could also have a preference, and also, as Anna said, member states that doesn't have these kind of infrastructures in their own country. So for each project, we will provide a travel to the site location and 1 week of accommodation, or if it's a remote access, which we also offering because of we have been develop a remote access just mainly for the pandemic then. So that will consist of more like a month of access, direct access, where we have weekly interactions with them. So in total it will be about the same number of days for each project that needs the full attention and training. So it will be training and analysis, database searching, so forth. We will also offer remote support before and after the visit, of course, until the user has to provide a result in a report within about 6 months, and of course he will also be supporting during the writing and the analysis at home, and he needs to write an evaluation in the end also, how it went, and that will of course will be fed back to the notes. So I think that was all for the access. Thank you.
Thank you, Ingemar. Are there any urgent questions for Ingemar? Okay. Then in this case, we can proceed with the next talk, which is on the standards, on the integration standards, and it will be given by Ying Chen from EGI Foundation.
Sorry, can you hear me?
Yes, we can hear you.
Okay, I'll try again. Can you see my screen?
Yes, but you have to make it larger.
Is it better?
Yeah, it's fine
now.
Yes,
Which
it's fine.
Okay, thank you. Sorry about this. Thanks for Anna, and thanks for Ingemar, which Anna present overview of the project, and Ingemar give you the aspect for the physical facility that provide for the researcher. My talk is more related with the e-infrastructure aspect for this project. This related to the objective 2 that Anna presented is to building the e-science center and provide e-infrastructure integrated tool for facilitate researcher in the PITHIA community. And this work is more about the designing of the e-science center, not the real work. The e-science center infrastructure is not existing, not provided yet. And so this task will be delivered by Working Package 1, that lead by EGI Foundation. And we are, if you know or not know EGI Foundation, which is coordinating the Federation of EGI e-infrastructure, that is the Federation of e-computing resource over European country and provide cloud storage and facilities, which is one of the biggest among the world in such kind. I'm in China. I'm working EGI, and I will mainly working package 1, okay, and outline for my talk is I will talk about why we're doing this work, what's the area, what we are going to do, and the scope of the work, and the standardization processing we're going to do, and some output for this task. And yes, as Anna mentioned, for the project is actually, as I know, is the first time for researcher, a community for upper atmospheric coming together at such big scale to try to deliver the interoperability, integration, access for the data and facilities. So, and to provide such integration tool will highly facilitate in the interdisciplinary and cross-discipline research. We already identify some of the use case which proposed by the PITHIA researcher, and this is integration of data and by easy to access the data facility, data model from different organizations, different observatory will highly facilitate the researcher to deliver new research, and which lead to new discovery. And providing this e-infrastructure, e-science center facility will provide a single access point to use and sharing such observation data, models, application, innovations, which highly facilitate the accessing all these resources, and also reduce the duplication from different development at the different site. We can also sharing our experience of all the existing models and development. It's also provide opportunity to optimization of observing strategy and node operations. So it's a very important work. And the integration work we're talking about is to facilitate uptake of consolidated policies and standard for data type, models, ontologies, or data management, data quality control, data analysis model applications, user authentication, authorization, observing strategies, infrastructure for data exploitation. All this area is our area we want to look into and bring into the community all the fruitful result from other related communities such as Ionosphere, using existing standard as much as possible, not reinventing wheels, but also create a standardization for our community. This essentially will ensure the sustainability by consolidation and integration with all the stakeholders within and beyond the consortium. And so we already collecting a list of the data set, data product to be registered in PITHIA eScience Center. All this data set and data product from different node infrastructure observatory of PITHIA is going to be registered and become available to access by eScience Center 2. Also, we have also planned to register all the existing analysis tool and from different observatory and organizations will be available to provide it to our researcher, and to integrate all this data set from different organizations. We choose to use a standard approach. Arguably, standard approach is still very practical way for interoperability and integration of data and model services. So we began to identify some related relevant standard which can be probably useful for PITHIA data model and service, and including space and this data model from a space physics study, or ESPAS, which is developed by Near Earth Space community. We use this standard as the basis, and but will extend to meet the requirement of PITHIA community for collecting data, accessing data. Also standard for creating models and creating services. We began to collecting all these related standard for integration work. And how we're going to work, we will discuss with our infrastructure provider, facility provider, to look at their existing data model, data type, ontology, what they're already in use, and then we look at their data to see how to mapping these standards to their data. We are also going to looking at outside, to looking other community, to if there anything relevant we will bring into PITHIA. This working package 1 is mainly will deliver this data management policy. Also, our work here, it will be the input for working package 5, working package 6. The working package 5 in the next talk, Gab will present you how the final eScience Center will be look like, and so working package 1 will provide this input to working package 5 as a requirement and standardization standards input for the development and deployment task in working package 6. And that's come to the end of my talk, and we will continue to collecting standards. So if you have any suggestion for community standards, please come to me, come email to me, and we will very happy to see your input. Thank you.
Thank you, Yi. It was very clear. Thank you. So do you have any questions for him? Okay, in this case, we can proceed with the next talk, which is the eScience Center, and the talk will be given by Gabriel Pierantoni from the University of Westminster in UK.
Good afternoon, everyone. Can you hear me well?
Yes, Gab, we can hear you.
Good afternoon. Thank you so much for inviting me. That's much appreciated. And I will try not to take too much of your time, and I'll take about just a few minutes to highlight the work we're going to do in Work Package 5 for the design and development of the PITHIA-NRF eScience Center. Can you all see my slides?
Yes, we can see
that
your
is
slide.
wonderful. So, okay, of course, there is a... Okay, so as Anna said, PITHIA is conceptually made of several nodes. And then we can see each node as a collection of users, of models that users use to investigate data sets, and then computational resources upon which these models are being executed, and of course, ideas. People do share ideas within their nodes, and then it is our aim as PITHIA to make this as joint as possible within all the project. And so our idea is to build something that is more than just of the sum of the functionality of its nodes. So something that brings together ideas, models, and resources on each of the nodes to build something that is greater of the sum of its parts. So in order to do that, we do propose to, the first thing is that we want to grant common access to all PITHIA-NRF. So have a single way to access the various facilities developed and accessible in each of the nodes. And then such common access would also be used for users to combine models idea to pursue combined research and multidisciplinary research. So that's the first aspect, is access to PITHIA. The second aspect is interoperability of the various models in PITHIA. So models will be able to run within those nodes, the original nodes, and accessible through an API if needed so. But also if the model owners desire so, they will be able to be executed in a common infrastructure that comprises both the nodes and heterogeneous cloud resources. So like if a model needs more resources for scalability purposes, we need additional space for storing both data sets and results, then our aim is to make available a cloud infrastructure, a heterogeneous cloud infrastructure, whereby such models can be executed, such data can be stored, queried, and retrieved. So, and the last concept in PITHIA, which was an interesting aspect of the proposal, is how do we share ideas? And in order to facilitate the sharing and building of common concepts and research ideas within PITHIA, we do propose to use a component called KREL. Knowledge, like the acronym, is a bit complicated and awkward, but it's knowledge, resource, and learning management. So we aim at creating an overall picture of the project where people can contribute and learn from each other within this component. Now, the main idea, as I said before, is that models can be either executed as they are in the nodes, and they will be accessible to an API, should the models owners desire so. But if they want to also run them on demand or on a cloud infrastructure, then we will propose a concept based on, well, it's a computer science concept called reference architecture, whereby the model structure and the required tools are expressed, and they can be executed, deployed and executed on demand on cloud resources when they're needed. Now, in order to achieve this, we have broken down the PITHIA-NRF infrastructure in various components. And here I will focus on the functionalities rather than the technologies. I will talk about that a bit later. So at the top, of course, we'll have a centralized, easy to use interface, then which will use user management to grant authentication, to check for authentication and grant authorization. Then there will be a component to query both models and data sets, which we call a registry. And now I couldn't put them all on top. Sorry, there is some silly phone. I apologize for that. And I couldn't put all the components on top. So the fact that they are stacked one upon the other doesn't mean that the Science Center GUI will not connect with the knowledge sharing. It just there wasn't enough space to put them all on top. So there is also a knowledge sharing, the KREL component, which I mentioned before, to share ideas and demonstrate the solutions that the PITHIA-NRF nodes designed. And then a manager that will manage the reference architectures in conjunction with the test and monitoring system. So we can see from the arrows, the manager will handle the execution of the various models, and then their access will be granted from the registry. Now we have investigated some. I'm not gonna bother you with acronyms and details, but like just to give an overview, we have investigated suitable technologies to implement the various functionalities. And at the moment, there are three boxes that have not been investigated yet, which is the graphical user interface, the composer of the reference architecture. So how do I compose the reference architectures, and the test and monitoring. We're looking forward, of course, with talking to EGI in developing and testing and monitoring system, and also with Work Package 6 to define interoperable components that are both effective and easy to use to the domain scientists that will use PITHIA. Now, this is to mention the work that Ian so kindly addressed before, and there is going to be a significant overlap between the definition of the eScience Center and an effort for standardization. Then, of course, that will cover the user management, and Ian so kindly provided standardization systems for user management. Of course, registering both models and data sets. We have had discussions on how to describe the data sets, initial discussions on how to describe the data sets and the models they both consume and produce. And then a standardization process in defining the reference architectures, and of course, testing and monitoring. Now, this is just an overview on how we would propose to use the knowledge, resource and learning component. We break down the overall view in two layers. The top one is the overall research concept of PITHIA-NRF. That can be described as a graph. I will give you an example in the next slide. Then we will have a material on how this is implemented, and that's on the gray on the right-hand side, and then yellow, which is learning curves on how to understand both the theoretical scientific research concepts and the technological implementation of that. And then, of course, for each of the scientific case, we can detail with subgraphs each of the concepts. So let's say that we have the overall PITHIA-NRF research goals, and then we may have a graph for magnetosphere study, one graph for propagation models, for coronal mass ejections, one graph that links the two concepts together, and so forth. We have, no, I don't have the slide of the example. If you want to see it, I can actually open it in a second, because that's in the full slides I have. Here. Okay, so full, yeah. These are the slides I have killed, not to annoy you too much, but so the idea we have here, and that's one of the first proof of concept we have created for the knowledge research and learning, and also a reference architecture. We took one scientific case, which is the investigation of STEAM, uses AC satellite data. And then here we have a simple learning curve. That's just an example about STEAM data. So we ask ourselves, where the STEAM data does come from? It comes from the ACA satellite. Where is the ACA satellite? Is on Lagrange 1 point. And then we can enrich these nodes with all the required links or videos and so forth. And then another graph that details the reference architecture that we developed as a proof of concept in conjunction with NOAA to execute the STEAM model outside of the NOAA node, and it's now running on in AWS cloud. So that is, I'll go back to my presentation. Yeah, and that was all that I wanted to say for the moment being, apart from a very, very brief overview of what are the current activities. So we are now starting the process to formally gather the user requirements and create a first design user requirements and design specification. I have received many much useful help and comments from the PITHIA partners for that. We have started working on a proof of concept, and we have worked on two first proof of concepts on the STEAM data analysis. Sorry, I forgot to change that. And then also in the support of Jupyter Hub as a tool for scientists. And then this also is linked to the first release due in month 12 of the eScience Center. I do thank you all for your kind attention, and especially for being so generous with your time yesterday afternoon.
Thank you, Gab, for this presentation. I would like to ask everybody if there is an urgent question for Gab.
I hope not. I got urgent
Okay,
questions are
okay.
stressful.
Okay, great. We can continue with the next talks, and then if there are things to discuss, we can do this in the discussion slot. Now we have two more talks from the consortium about science cases. The first talk will be given by Lucas Bogli from INGV. Luca will present the science cases on modeling advances.
Hello, everybody. Can you see my screen?
Yes, Luca.
In a presentation mode. Okay.
Yes.
Yes, I would like to show you some examples of scientific cases that can be addressed thanks to the PITHIA capabilities, in particular how PITHIA can support scientific modeling advances. Okay, so this is the, as you see, the PITHIA universe that includes a lot of instruments, models, data, and I briefly report here, but these are just a few examples. We have models, for instance, this is the SWIFT and the IP models. We have a lot of capabilities in terms of tech models at regional and global levels, and I will talk about it a little bit later in my talk. And then we have the possibility to integrate the iSCOUT observation together with the GNSS observations that enhance a lot of study addressing the irregularities in the formation and dynamics and morphology of irregularity in the ionosphere. Of course, we have a lot of capability in terms of HF soundings with several ionosounds made available within PITHIA. And again, we can study the scintillation events, so the effects of the ionospheric irregularities on different bands. Here we have, for instance, the L band of GNSS signals and the VHF band of LOFAR. And we have also modeling of the planetary ionosphere. This is a video of the Mars model of the Martian ionosphere, but this is it is just few examples. We, of course, PITHIA can offer a lot more. One of the scientific challenges that can be addressed and to improve the modeling is the effect of small and middle-scale ionospheric irregularities by integrating GNSS observation, LOFAR, VHF through the Kyra network, and IceCat observation. In particular, the LR and INGV that are part of this the consortium own a lot of scintillation receiver. Here I've just reported the one that are operated in Europe by the two institutions that allow to study amplitude and phase scintillation of GNSS signal triggered by irregularities, the small scale irregularities in the ionosphere. And the LOFAR, Kyra, and IceCat allows to study the scintillation also in other bands covered by the different wavelength of the investigating receivers, and to study then not only the modeling based on the weather conditions, but affecting mainly the high latitudes, for instance, in those examples. But the new solar cycle would enable also the possibility to study the spillover of the irregularities that can happen under strong and extreme space weather event, either from high and then low to low latitudes, so driven by completely different mechanism of the magnetosphere, ionosphere, thermosphere coupling. Another good example, that is again based on the different capabilities provided through PITHIA, is the modeling of the effect of solar flares that can be done by integrating the TC from GNSS observations, from the ionosonde observation, and from VLF, affecting in particular the layer in the ionosphere. In this part, in the left part of this slide, there is a very quite known results that has been obtained by Surutani in 2005 that demonstrated and show the dependence on the distance from the subsolar point on the TC enhancement triggered by one of the largest flare that occurred during the Halloween storms in 2003. And of course, this exercise can be modeled also because PITHIA gives access to 4 TC mapping providers, including global ionospheric mappings, because part of PITHIA, UPC, ROB, DLR, and INGV that are providers of those kind of maps at regional and global level are within PITHIA. And here in the middle part of this slide, I'm reporting also an example of the facilities that can be used through PITHIA by integrating the Ionosonde and the GNSS observation for TC modeling. And I'm also reporting in the bottom part the so-called GIFDS, so the Global Ionospheric Flare Detection System owned by the DLR that allows monitoring the flare effect based on VLF observation. And again, there's another example of how we can tackle the flare effect also at the regional level. I'm reporting TC map deviation, TC deviation map over Italy that has been recorded in correspondence with the X9.3 flare that occurred in September 2017. That is the largest flare of the past solar cycle. So by combining the different footprint of solar flare of the various instruments provided by PITHIA and data product, not only instrument, can also enable the modeling, modeling and the estimation of the solar flare location directly driven by this multi-instruments approach. And another example I would like to report is, for instance, the modeling that can be performed of the traveling ionospheric disturbances. Here I'm reporting an example of large scale, but of course on middle scale, and in general, also traveling atmospheric disturbances can be studied and modeled by integrating optical, GNSS, magnetometer, and HF instruments provided by PITHIA. In particular, in this part of the slides, the top left part of the slide, there is an example of TC variation map triggered by a large-scale TID occurred in July 2017 by leveraging on the TC mapping provided by one of the PITHIA providers. Of course, this kind of disturbances can be monitored also by using the total electron content evaluated over single station, or can be monitored by investigating the triggering phenomenon, for instance, by looking at the magnetic disturbances induced at ground. This is, for instance, an image taken from the paper by Cesaroni et al. Published in JGR 2017. And in PITHIA, we have the Finnish pulsation magnetometer chain station that are included in the image chain network. In this part of the slide, so in the middle bottom part, there is an example of the same TID that has been detected by using the TC single station and the image network that passed over Europe in November 2012, and is part again of the publication I cited, like I just cited. So this is a way to feature the LTS ID by using ionosondes, and we have also the possibility to feature the STID by using the all-sky imager. This is an example taken from the Asiago all-sky imager in PITHIA. It will be available, the all-sky imager that will be installed in Lampedusa. It was Lampedusa is the northernmost island of Italy, so it covers almost the same field of view in terms of spatial coverage, but of course shifted to lower latitudes with what reported for the Asiago. It should be installed as soon as possible. It was foreseen before the starting of PITHIA, but the COVID pandemic emergency has shifted all this, the installation of this all-sky imager. But of course, we will do our best to make it available as soon as possible. And okay, I'm just willing to report some take-home messages. So facing cutting-edge challenges, and ionosphere, planosphere, thermosphere modeling requires a real integration, a mapping observation of this nature that with PITHIA we will really like to enable, because PITHIA is willing to be a one-stop shop to allow scientists accessing multidisciplinary, multi-instrument data and models, sorry, not just model, advancing the knowledge, and then consequently the modeling capability for space weather warning, forecasting, and mitigation. And in 10 minutes time, I had only the possibility to show 3 out of many examples that can be addressed during the lifetime or in the near future for users of PITHIA by exploiting the system we are doing our best to build up and realize. And this concludes my contribution to this event. Thank you.
Thank you, Luca. Many thanks for this. Just to say that we are trying to to keep our website always updated, although the website now it is under development, but still we have uploaded a number of science cases. So you can visit the website and check there for additional science cases. And in the future, of course, we will upload many more science cases from past work, but also results from the projects that the users will implement in our nodes. Okay, do you have any questions for Luca? Okay, in this case, we can proceed with the next talk, which is it will be given by Hannah Rofkal, and Hannah will present science cases towards innovation.
Hello, good afternoon. Do you see my screen?
Yes, Hannah, we can see your screen.
Okay, thank you very much. So in the PITHIA project, I have a pleasure to lead work package 4 devoted to establish innovation platform. Today, I will to give you a short overview of our activity and some selected science use cases relevant for innovation. In fact, it will be, I also choose one similar example as Luca, but nevertheless, it showed that it is very important topic. So based on the PITHIA consortium achievement, we are willing to share the collected information about the upper atmosphere field condition and create the easy access to it. The innovation platform can be the bridge between the science community, space weather services, and industry community. The activities in particular will include the maintain and further develop standard making processes for data products validation and related software to promote systematic use of PITHIA nodes for calibration and validation of novel instrumentation, and to establish a platform for exchange of expertise information with stakeholders for promotion of joint public collaboration for high-risk innovation and close to the market activities applied by PITHIA. So the innovation platform will be the important mechanism to integration the PITHIA research and will be a platform to meet with wide spectrum of users and also to exchange the expertise and testing new instruments. Somehow, it will be a platform and place for common activity which will benefit for both sides. So we will have some expertise from PITHIA consortium as well from the we'll get some user expertise. So this is very important issue. To meet these goals, we will have the different type of product prepared on the base of integration process in infrastructure modes that will include, as you see, forecasting, observation, and modeling. And all this will create the product, innovation product. And what is important that this product we can offer as a consortium for GNS, HF aerospace solution and observing instrumentation, for networking with PITHIA expert for knowledge transfer, and it can also be used for experimentation on use of research infrastructure and of e-science tools for validation, calibration campaign. This is also very important, and for design of new data product. And now let me show 3 examples. I also choose some different type examples on which we will working, but it is not the whole story. First one will be for using multi-point and multi-instrument diagnostic for quantification the impact of magnetosphere ionospheric coupling on aurora region boundary layers behavior, using in particular satellite in situ measurements from the past experiment, the Meter, RELEC, and operating cosmic and swarm satellite, as well as for measurements coming from the ground-based infrastructure, and also contribution from existing models. So the main ionospheric trough is a very interesting region in Earth environment. This is a projection of plasma poles to the lower altitude. This large ionospheric structure can have also significant impact on the other ionospheric regions. And due to the complexity and variability of this system, which may be impacted by the processes taking from near environment as well as from remote area in the Sun-Earth system, we can use wideband diagnostic located on the space as well on the Earth surface for description the condition of the structure. As you can see on this plot, we can use the data coming from the swarm satellite, which orbit is located from 500 to 800 kilometers. I would like to use the IceCat data. We also use the map prepared by the help of networking Ionosonde Europe and Triomet networking system. But what is innovative that we can use also some data coming from the LOFAR International Station diagnostic, and you can see here the some signals coming detected in a single station. But we hope that such kind of attempt will give us more detailed information about temporal and spatial evolution of this structure. The second example is very similar to the LUCA, but we would like to more concentrate of the diagnosis of the morphology and velocity of small and large-scale ionospheric structure. As it was mentioned by Luca, all this previously operated system as IceCat magnetometers and optic measurement GNS data and HF diagnostic. But what is new that we would like to propose use some methodology which will allow us to determine the velocity of the small scale structure, and you can see here some that we can get good agreement with IceCat measurements. That this map are created by IceCat facility, and these are coming from the LOFAR measurements. But also we are able to determine the structure of the ionosphere, for example, determine different layers in the ionosphere. So this is something new, and also thanks to increase of the signal level sensitivity for scintillation signal obtained by the LOFAR, we will be able to obtain the information not available till now, for example, by the GNS measurements. And finally, I would like to pay your attention to the H-frequency communication and propagation of the signals. Recent years show that HF frequency communication again became a very important tool for communication in special region of our planet. So HF radio equipment need a model of the ionospheric radio channel and its short-term perturbation. So again, recording the real-time ionospheric radio channels under different ionospheric conditions by simultaneous PITHIA observation and modeling would provide a set of excellent standard ionospheric radio channels. So you can see that we have a lot of ideas which can be implemented in our project, and we hope that will increase the quality of the modeling and also of the services which we will prepare based on our node activity. Thank you very much. This is all what I prepare for today.
Thank you, Hannah, for this presentation that demonstrates very nicely the challenge of PITHIA to go from the science output to operational products that will lead to innovation. Okay, and now I believe that we can start the last slot of this meeting. And I understand that we have 3 presentations from our advisors, from Joe, from Mamoru, and from Odd. I don't know if other advisors wants to, maybe Joseph wants to make also a short presentation. Okay, in this case, we can start with an introduction from Nicolas on the main challenges, and then we can have the presentation by Joe and by Mamoru and by Odd. Okay, so Nicolas,
yes,
you can
hear me?
Yes.
Yes. Can you see my screen also?
Yes.
So good afternoon, everyone. So we identified several topics to be discussed during this discussion part. The first one is what the research community can get from the PITHIA-NRF. So what can we bring for the next challenges in fundamental research and general research for people which plan to use the PITHIA-NRF? The same question is also for the operation sectors, so more the SMEs, so the small and medium enterprises. After, the other topic is which link we can have with European or international project or initiative, research initiative, to become a part of the upper atmosphere ecosystem, a representative for Europe of the upper atmospheric community. And after, the last one was, what are the changes towards sustainability? So I don't know if you have time, Anna, to discuss every question, actually. Or if I present what we have highlighted for these topics.
Maybe, Nicolas, you can present our thoughts on each of the topics, and then our advisors can give their presentations. And on this first view graph under the challenges for the research community, I believe that we have 2 presentations that fit nicely, one by Joe and one by Mamoru. Okay. So you can present this point, and then Joe and Mamoru can give their presentations.
Okay. So the challenges that the research community can get through PITHIA. So we highlighted different challenges. So first of all is to increase the awareness of young student, postgraduate student, and young researcher on new research opportunities offered by the transnational access program and through the eScience Center. The other is to share all the information. For the first time, PITHIA-NRF will offer a research environment to researchers and operators at all different observing facilities for the ionosphere, thermosphere, and plasmasphere. So it's really to give a complete tool and research environment to study all these different parts of the atmosphere and geospace environment. The possibility also to have a close and systematic interaction with the aim to share information, knowledge, and technologies, and also to train the young generation to the space weather in general. We also plan, one of the challenge is also to optimize the observing strategies. So for that, we will organize annual meetings on a workshop on the optimization of observing strategy. And one important part is to get the feedback from the users and to improve our observing strategies or infrastructures to be more easy for the users and more easy and more free to use. It's also to stimulate key scientific advances thanks to the open access policy and to quality certified data, and by validating and make models which are interoperable. We also, one of the challenge is the scientific production, and also to improve the quality and the quantity of scientific production, especially for space weather and geospace environment, and to push for a new mentality in data sharing, model use and reuse, and training. For the operators, so here is more linked to the small and medium enterprises and large organizations for design of actionable products to be provided. It's also to motivate the young scientists to join our field, which is very important now in Europe, because Europe is becoming a second-tier player, and we are losing our capabilities, while other countries, big countries, are putting a lot of efforts on this subject. We also, one of the challenges to support technology and to make some diagnostic experiments, so to support, for example, satellite operations, to support all radio wave based studies, even on planetary, on other planets, such as Mars. But for that, we need to support, to give some good models and to support this kind of technologies and new experiments. Also, one of the challenges to improve the forecast to protect critical technology, so such as satellites, communication system, low frequency radio, telescopes, etc., etc. The other big challenge is also to offer standardized services, strongly aligned on the open science and fair data, which is really encouraged by the European Commission and through the European Open Science Cloud. And standardization is a key for interoperability. And so for that, we will need to make some cross validation and calibration of data from ground-based and space-bound instruments. So this is also something that we can be useful for the operators community. Support advanced modeling and standard making processes for higher level data products with the use of quality control data. And finally, optimization of services that creates potential for the use of PITHIA-NRF nodes from small and medium enterprises and space agencies. Now, what are the challenge for sustainability? So for that, we need to have systematic use of the assets that we propose in PITHIA-NRF. So which means that PITHIA-NRF developments needs to have input from the users to improve the product that we will propose. It's also to establish a European, purely European hub for upper atmosphere and space research. For that, the challenges will be to provide optimized operation for research facilities, access to open data, access to open software, access to open methodology, guidance for operations, standardized training, and data and products. We will also, one of the challenges to support researchers, especially from countries who have no tradition in upper atmosphere research. And this will be done through the transnational access program and seminars. And we will have also a systematic, we plan to have a systematic networking with other research infrastructures and stakeholders to guide the governance and future funding decision. So another point also is to make the link to link our initiative with other European and international projects and research initiative to become part of the upper atmosphere ecosystem, which is already well done in other countries, well realized in other countries. So for that, we need to ensure complementarity and coherence with other research infrastructure in Europe and worldwide. Here we identified some different projects, so observational infrastructure like ESCAT, ESCAT-3D, LOFA, some research infrastructure or research web services like Actris, Arise, Arise2, TechTide, SWAMI, and international centers for space weather and for meteorological also stuff like the ESA Space Situation Awareness. I will just pick up some NASA, CCMC, COSPAR, etc., etc. And also to one of the main achievements in Europe for all this kind of how to say that, how can we build a service to public and private sector is a Pegasus project, which is a consortium between different countries in Europe and South Africa to provide alerts to the civil aviation when there is an expected impact of space weather on different instruments on board the plane, the airplane, such as GNSS, radio communication, etc., etc. We will also, so to make the link with other European and international projects, we will organize public events. So today is the first edition of the public event. The goal is to discuss with partners, advisors, and stakeholders what exists, what needs to be developed now. And we will also actively participate in the European Research and Innovation Days. So these are the four questions which we wanted to discuss with all of you. But maybe you can give the screen now to Joe Uba to present his their infrastructure at NASA, I think, for ionospheric, plasmaspheric, and thermospheric modeling. If you have any comments or question, you can discuss this after the presentation from from Uba. Thank you.
So can you see my screen?
Yeah.
Yes.
Okay, good. All right, this is something of a science talk, but highlights, I think, some new results that could be addressed by this program. I won't elaborate this, but we have a ionosphere plasmosphere model, SAMI-3, that was developed while I was at the Naval Research Lab with Glenn Joyce. That's been making a lot of progress over recent years. And in particular, some of our recent work, we've coupled to the thermosphere, in particular to the NCAR WACM-X model, which is again a ground to 500-600 kilometer thermosphere, whole atmosphere model, as well as the Haya MCM model, which is Eric Becker's thermospheric model. And we've one-way coupled the codes in that WACM-X and Haya MCM provide thermospheric variables to SAMI-3, but at this time we're not feeding ionospheric data back to the thermosphere. But be that as it may, what we've done, I believe the highest resolution ionosphere thermosphere models run to date were the first principles physics code. For Wacom X, the lat-lon resolution was about 0.47 degrees, 0.625 degrees in longitude. This is on the order of 70-kilometer gridding. On some of the recent work with high MCM, we've gone a little bit finer with a 0.5 degree resolution. So we have 50-kilometer gridding. This is global. SAMI-3 uses the same longitude gridding as these models, but its latitude gridding is variable. Near the equator, it's relatively fine at about 17 kilometers, and nominally is 1.5 degrees at high latitude, which is 170 kilometers. So this was some surprising work that I did with Hanli Liu that came out last year, where in using the Wacom X model to drive SAMI-3, the Wacom X has atmospheric waves and gravity waves, and they acted as a seed to trigger equatorial spread F bubbles. And on the far right here is a image from the GOLD satellite mission of 135.6 nanometer emissions. And the bright red stripes is basically the ionization or Appleton anomaly. But then you can see striations. Well, I don't know what happened there. Boy, oh boy.
Maybe go to view.
I hit zoom by mistake.
Go to view on the top left.
Well, let's see if it's supposed to zoom into the actual page, and I hit the wrong selection.
But
So,
if you go to
what?
view on the top left on your PDF,
Oh, I see.
you don't have full screen, for example. No.
Well, if I go to full screen, I've had trouble.
Okay.
That's why I'm showing it not in full screen. I
Okay, sorry.
accidentally hit a view, but that's okay. But I'm back here to where I want to be. Yeah, you can see. So the bottom line is, when we did this model, surprisingly, we generated these irregularities within our code, which resemble quite closely the GOLD observations, though we weren't doing this particular day. The GOLD observations were for an October time frame, and we did a March. So they were both equinox, but not the same conditions necessarily. The middle panel is the simulation result on the same color scale as the GOLD selection. And it just shows that the emissions from our model aren't as intense as GOLD observed on that particular day. On the far left, the color scale was changed to highlight the striations and show the similarity, at least visually, between the simulations and GOLD. So this was pretty remarkable that we were able to capture this. But the point here is whether or not these types of equatorial irregularities can make it to Europe remains to be seen, or is it ionospheric disturbances from high latitude, as we discussed earlier? That's another issue that I think can be addressed. But the new thing here that is the following: is this is isosurfaces at different levels. The yellow is 1,000 per cc, the green is 10,000, and you can see some red here. That's about 5 times 10 to the 5. So when you play this animation of this simulation, here at the end, you can see in the red there are stripes here. Okay, so these are these equatorial irregularities that form that I showed in the previous view graph. But when you blow this up, what you find is, in fact, the plasmosphere becomes structured and corrugated, and ducts are forming. You can see here on the left in the green, and out in this outermost part, it's structured and corrugated. And this is associated with the thermosphere and atmospheric waves from the thermosphere, not only modifying the ionosphere, but also modifying the plasmosphere. And so I think this type of program that's being proposed may be able to investigate this type of phenomena, which to my mind has been relatively unexplored, and I think is new. Just in terms of a visualization, there was some work done in Australia in 2015 by a student, Loy, and they had made this image from their radio interferometer experiments showing plasmaspheric tubes and ducts forming. And it's maybe a bit much, but nonetheless, in our model, we do see duct-like formations, at least visually similar to what has been observed. So yet this is some other evidence that perhaps, these ductings we're seeing in our model generated by thermospheric waves is real. We'll skip that. And the last point is, rather than vertical TEC, I made calculations of flux tube integrated TEC to try to show if you have regions of higher or lower plasma within the plasmosphere ducts. And in this simulation is one example of this calculation of, again, not vertical TEC, but flux tube integrated TEC. The top panel is for a high MCM SAMI-3 simulation, where SAMI-3 was run at low resolution. The longitudinal spacing was about 4 degrees. The bottom panel was for our high resolution case, where SAMI-3 was run at 0.5 degrees. And the only issue I want to point out here is simply in this red middle area at the top, it's relatively smooth. But down in this region here at high resolution, there are closed contours. And the fact that you have closed contours indicates that there's a localized increase or decrease in the TEC in these regions. So these can lead to ducting formations, which could have impacts on, say, VLF propagation. So I'll just close it out. Just the point here is simply, this is a new result, at least from the modeling point of view, that we're getting plasmosphere ducting and corrugations in the plasmosphere. And these are occurring at mid-latitude. So presumably with our program that's being proposed, I think it would be interesting if, this could be investigated, since it is new and is associated with, smaller scale structures, not just in the ionosphere, but also in the plasmosphere. So thank you.
Thank you, really interesting. Any question for Joe?
Joe, can you send us your presentation for our website?
Sure.
Can we make it available publicly?
Sure. Yeah, I can send the presentation to you.
Okay, because we would also like to go through the references and understand better how this model works, and if we can at least use the main principles for further studies.
Yeah. So somewhere down the line, if there's a computational facilities associated with this program, we could perhaps put the code there and other people could use it.
Oh, okay.
I mean, that would be something that I think might be helpful.
Very interesting.
Yeah.
Great. Thank you. Okay, now.
Yes. The next presentation is given by, I don't remember.
Mamoru Ishii.
Okay.
Okay, can you see my slides?
Yes, we can see your slide, Mamoru. Thank you.
Okay, thank you. So thank you for inviting me, and good evening from Japan. So today I would like to introduce our recent plan for research, which may contribute to the your new project, PITHIA-NRF. So I choose some ionospheric spaces monitoring and forecast from our whole project. Okay, this is a schematic plot of our NICT work plan, which just started on the last April. So, as you know, there are some fields in the space weather: sun, solar wind, magnetosphere, and ionosphere. And in each part, we have observation, forecast, and dissemination, and provide applications. So we emphasize in observation, we prepare space weather monitoring with satellite and airborne observation and filling gap area of ground-based observation and international cooperation. And for forecast, we start data assimilation with observation and numerical model fusion, and also AI-based experience model. And yes. So this is our ionospheric observation network. We have 4 observatories in Japan: Wakkanai, Kokubunji, Yamaga, and Okinawa. And also under the international cooperation, we have several number of observatories in Southeast Asia, especially for measuring the equatorial plasma bubbles, which already mentioned in the previous presentators. And also in South Antarctica, we have ionozones in shower stations. The most recent activities for observation is we installed the new VHF radar in Chumpon City, Thailand, for detecting equatorial plasma bubbles. Here, this is Chumpon, and this is a cartoon of the plasma bubbles, and this is the opening ceremony. It was held on the January 2020, and unfortunately, we have difficulties to go to visit here under the COVID-19, but several observations have succeeded. This is an example of the data assimilation with numerical model in operational space weather. So we have been developing the atmosphere-ionosphere coupling model named Gaia for forecasting ionospheric condition as a part of space weather. And in this midterm plan, we start the operational use of this model with data assimilation using the ground-based and satellite-based data. The latter one is rather different from the ionosphere. It's a prediction model of the solar wind, which is also important for space weather, but I omit this explanation today. Okay, this is an example of the application named HF-START. So HF-START is a HF propagation simulator that is developed to meet the needs of space weather users for, but not limited to telecommunications. So we have 2 modes of these models. It's a Japanese regional model, and this is a global models. For a domestic model, we can use real-time ionospheric tomography data used with the GeoNet GNSS data. We have 1,380 GPS receivers in Japan. It's a very dense network. And using this data, we can deduce the real-time ionospheric density profiles. So using that, we can deduce the HF propagation in the domestic models. And in a global model, we use a Gaia numerical model for detecting the HF propagations. We can use this model in the website. So if we are interested in it, yeah, please visit this site. Okay, this is an international activity of NICT in Asia. So we also collaborate to the IKO activity as a member of HCFJ, Australia, Canada, France, and Japan. And we have some ionospheric data exchange with BOM. And also, we have some technical cooperation with Thailand, GISDA, and cooperative observation with Korea, with ionospheric observation with oblique soundings. And for data exchange, we start collaboration with Taiwan for data assimilation with Cosmic Formosat 7. We use this satellite data for Gaia for real-time data simulations. And for data exchange cooperative project, it's also a capacity building. We install some GPS receiver in Thailand, Laos, and Myanmar. But as you know, Myanmar it's a very difficult situation now. So yeah, it's a rather pending status. Okay, my talk is over there. So thank you for listening.
Thank you, Mamoru. Thank you.
Mamoru? Sorry.
Can we have your presentation uploaded in our website for public access?
Yeah, okay. I will check and yeah, we can provide you as soon as possible.
Okay, thank you. Thank you. And regarding the, your data, I believe that at least the data that are openly available can be considered by PITHIA also for future integration in our eScience Center?
Yes, our ionospheric data is almost all of the data open, so you can access it.
Yeah, I mean to develop some reference so that our users can easily discover your data.
Yeah. Yeah.
Okay.
Yeah.
Yes.
Are there any questions for Mamoru?
I'm sorry.
No, okay, Nicola, go ahead.
No, I thought there was no question for Mamoru. No, but there's a question in the chat for Joe about the SAMI-3 model. So this is from Joseph Lemaire. Does the SAMI-3 model of the plasmasphere include the plasmaspheric wind expansion?
I don't fully understand, perhaps.
It's in the chat, actually.
Yeah.
Joseph Lemaire is asking you in the SAMI-3 model.
Plasmasphere wind expansion?
Yeah.
I guess I simply don't understand the question.
Do you want me to repeat it? Or
I can read it. I don't understand by plasmaspheric wind. What wind?
Okay. So maybe Joseph, you can.
Well, I guess which option we have shown that there should be.
Sorry, Joseph, we can't hear you really well.
Hello? You hear me?
It's really low.
Yeah. I just wanted to know if anybody has really taken into account the expansion of the plasmosphere.
We still have an issue with the sound. I cannot hear Joseph.
Some cluster observation by Ioannis Dantouras have shown that there is such an expansion, greater expansion of plasmosphere.
So just to be clear, with the cluster mission, you see some plasmasphere.
I mean, I'm not sure about what you mean by wind, the neutral wind or the plasma wind along the field line or perpendicular. I mean, we've done studies with storm time studies where we encode the plasmasphere, and then we do studies of the refilling of the plasmasphere. So in that sense, there's certainly an upward wind of plasma coming from the ionosphere upwards into the plasmasphere to refill it. That type of wind, if you want to call it that, is included. I'm not sure if that completely answers the question, but it's a relatively comprehensive model.
Well, I think that I'm not understanding what your point is. You know, it's the evidence that the plasmosphere is expanding can be seen from with your observation. You see, if you look at the carpenter's knee, it is moving from time to time after an erosion event. And so this is evidence that the plasmosphere, the plasma cores and the plasmosphere is really expanding gradually, like it has been shown by Dantouras, using cluster observations. And I wonder if your model is including such a dynamical expansion. It's similar like the solar wind.
Yes,
it doesn't include the solar wind per se. I have difficulty hearing you. Perhaps you could send me an email and we could correspond that way, and I could address some of your questions.
Okay.
Okay, thank you.
Okay. And I believe that we can now proceed to the last presentation by Aude.
Okay, can you see my slides?
Yes. Can you
yes,
present it in full screen?
Full screen.
Oops, sorry. Is it better?
Great.
Yes, perfect.
Okay, I can't see exactly what you are seeing. So, we spoke about science. I saw all your organization and so on. I'm sorry. I hope that I will not annoy you. Now I will go on the point of towards open science, open data, and what I will present you is really high level. I will not go into details, but I saw on some of your slides some points that they appear really important to me, and yeah, that may be just the opportunity to discuss or for you to explain me in the PITHIA-NRF project that you already foreseen these possible challenges and so on. So just to speak about the data ecosystem, as far as I understood, reading the website and listening to your talks, the data you are working with are really heterogeneous data, but there are also dynamic data with observations of non-stationary systems, diversity of use, and transformation of information throughout the data use cycle, in fact, because you are doing models, simulations, which may be seen also themselves as secondary data or data of different origins, as in silico data, as we are saying nowadays. So this picture is really the picture, my own picture. So maybe it's not really academic, but nevertheless, the relationship between the stakeholders, the data repositories, and the mean for calculations and developments. For me, it's really forming this kind of triangle. There is not a piece of the triangle that is more important rather than the other pieces. But nevertheless, this is really a focus onto all the interactions, and all the aim of that is to go towards services, towards users, for sure. I just would like to focus onto the data repositories because these are really the important, I mean, not the main one, but really an important stone into what you are building, nevertheless. So the data ecosystem and the related principles that you know for sure, but you know the fair data, which are they are snapshots, because fair data can be fair at the beginning, but if you are not performing curation onto these data, nevertheless, they are no more fair. So it's fair data. Fairness is at a certain time. You know that fair is findable, accessible, interoperable, reusable, but maybe you do not know also the trust principle. Trust is for repository. This is really on long term. It means transparency, responsibility, user focus, sustainability, and technology. For sure, transparency and sustainability here is really important. So if you are getting fair data which are not in trust repository, for sure they will not stay fair for a long time. And around that, there is the open science, open data, but the ecosystem of the users and customers, and also of the instances with the data sharing policies and directive. And this is the care principle, care for collective benefit, A for authority to control, R for responsibility, and E for ethics. But I will concentrate here mostly onto the trust and fair principles. So just recall bigger just logos. The fair and trust principles, you know well that, and because you did this project, you are all in different ERC maybe, and working in data repositories, exchanging data with colleagues and so on in Europe. So the fair and trust principles are really a long-standing European concern. Here I did not update those slides because I'm keeping, in fact, the genèse of all of that. In October 2017, research data repositories were already described by Europe as trusted research data repositories with fair data principles for sure. But there is also the International Science Council, which is the organization that is the main body that is also around WDS, the World Data System on CODATA, to IC, and especially the group of European IC members. They have done in January 2018 also a statement saying that data repositories ensure long-term preservation of open data with fair metadata, with fair principles, and into certified trustworthy data repositories. So the trust is really important here, and that really won me when I saw the slides. And maybe this is just a typo, I don't know. I saw the slides, for example, of regarding the DOI onto services, and the fact that generalist data repositories, or repositories, not that forcefully data repositories, that are not experiencing curation, that are accepting all kinds of elements without any moderation on external checking, may be used, for example, to get DOI. That's really useful to get DOI into a fast way in order to directly be able to publish a paper, because you just have done the deposit of the data in a certain repository which is open, and you can just put everything without any problem. Nevertheless, as an advisory member of the board, I would just tell you since the beginning, just think about the possibility to put all the information, even the codes for sure, in thematic or institutional repositories that are going towards the trust principle. And repository tools, for example, they can go, I mean, softwares, they can go into or be embedded also into software heritage. There is not necessarily a standardization of interoperability into this, but translation is also possible. So just in that case. So just to follow on fair and trust principles, just some updates. For example, there is a certification, which is a Core Trust Seal certification of data repositories. There are some requirements. It's really an international basis now for all the data repositories in Europe on the international landscape. And this Core Trust Seal certification is included directly in the European Commission official ICT technical specifications. So for your project, maybe it's interesting to dig more onto the trust principle and to see exactly where you can, how you can aim for certain of your data repositories. And I'm sure maybe most of them are already perfectly fulfilling all their requirements. Just to finish, and that's open for discussion on the international landscape, just for you to be aware that yeah, there is open science, open data, open. We saw plenty of open onto the slide of Nicola. And Nicola recall also that there is a new mentality in data sharing and model reviews and so on. But nevertheless, as there is a kind of jungle, in fact, the 4 international data organizations really collaborate, and I've a joint commitment to work together to optimize for sure, and to be more visible towards the stakeholders and even the public, to organize the global research data ecosystem and to identify opportunities that will trigger federated infrastructure to service the new reality of data-driven science. So there is CODATA, GoFair, Research Data Alliance, and the World Data System. You know those names already, but nevertheless, now there is one gate you can go, and for sure, they are getting all core missions, main processes, and some outputs, but the aim is that these organizations are totally, are not specific to a specific scientific domain, and they are totally open and outside from any, they are totally independent, and their aim is really to build the ecosystem of open science worldwide. So that's just the points I wanted to underline here. I don't know if you are getting questions, but
yeah, thank you very much. It was a very good overview of all the challenges that we are facing with the data. Can we have your presentation for our website?
Yeah, I will transmit something. Sure.
Okay, great, because it will be very useful as a reference in our work. And although we were, I mean, we were aware about many of the challenges, you summarized everything there, so you made me very anxious and stressed at the end. Yes, and the data curation is a very big issue.
Yeah, it's really important. So I mean, I'm not saying that those generalist. I will not cite it, but these generalist data repositories are useful. I'm not saying that they are not useful, but the point is that in your project, I mean, this is a European project, H2020, and I mean, there is a big consortium, plenty of nodes, you are scientists. Yeah, I'm sorry, I'm just giving advice, but really, if it's possible to get thematic or institutional repository, to get DOI for sure, and to get reference and to be maintained, but not something that is just open to everything would be better.
Yeah, yeah, I see.
When you speak about DOI, so the DOI, is it for each model that is, because normally the models are linked to a publication which already have a DOI. So this is something that I miss in general, because some people put a DOI, you have a DOI for your data and the DOI for the model and the DOI for the publication, which have the data and the models. So
yeah, but for example, sorry, I will put my camera. I'm sorry, I forgot to put it. It's not really polite. There was a presentation saying that there will be DOI on services. And from my point of view, I mean, that was a presentation for, I can't get but it was one of the presentations. It was on slide 7. I think that was Yin Shen who presented that. Okay. And there was just a line written DOI and for services. And that was my concern, my question towards, I mean, we can put DOI, as you said, Nicola, onto data, onto models, I mean, with the parameters and so on. I mean, you are getting a publication for that, for sure. Onto data product, because a model can be seen as a data product. Yeah. Okay. But onto services, services are supposed to evolve with time. They are supposed to adapt themselves to new data formats, to new stakeholder demands. Yeah. So I totally, yeah, that was one of my questions.
Okay. You have to think about this.
Yeah, most possible, the DOI on the services is a DOI on workflows that will facilitate the development of new processes, computational processes. Yeah, maybe this was the idea.
Okay, so maybe I'm not aware of that, but I didn't know it was possible to put DOI onto workflows. Because is it DOI onto the process itself, or is it a DOI onto the document who describes the process?
This has to be discussed, but I believe okay. it is in the document that describes the process.
Okay. Okay, so that's different. You can put a DOI, yeah, because the generalist data repositories, they are most of the time used to put DOI onto step point or onto deliverable of projects. So it's really useful because you are just putting a PDF. This is the deliverable of the project. I mean, it doesn't need any curation afterwards or whatever. This is the state of something. So there's absolutely no problem to put in such as generalist data repository in that case, and to get a DOI in a really fast way. But to put data or to put, for sure, there will be never curation onto this data if you are putting that.
Yeah. Yeah.
Yeah.
Yeah. Yeah. This was a very good point, and we have to think about. Yeah.
Okay.
Any other questions? Although we are running late, but if there are any questions, we can discuss for 1-2 minutes. Okay. Okay. So in this case, I would like to thank you for being with us today. We will create a page in our website with the main points from this meeting, and make the link to the talks, those who have made their talk public, and we will also put the event in a video, so we will make this event available for everybody who wants to see what we have discussed. So this is, yes, Nicola?
Yes, concerning this point, so we created a YouTube channel, PITHIA-NRF, so we plan to put this video on this YouTube channel. So I hope no one has any objection about this. Just to.
Yes, of course. If you have any objection, you have to tell us.
Yeah.
Of course, we will also circulate an email later on to confirm that we have your agreement on this. Okay. So thank you very much, and I hope that we will be in touch also very soon with more developments from PITHIA Consortium. Bye-bye.
Thank you.
All right. Thank you.
Thank
Bye.
you.
Thank you. Bye-bye.
Bye-bye.
Bye.
Thank you. Bye.
Bye.
Bye. Thank you.
Bye-bye.
Bye. Thank you.